All right, so this is the first day of our rational unit. Do you guys remember what the word rational means when you're talking about math? Fraction. Means fraction. We talk about rational numbers as numbers that can be written as fractions. So like whole numbers are rational because you can write like the whole number 5, you could write as 5 over 1. 0.5 is a rational number. It can be written as 1/2. So rational numbers are numbers that can be written as fractions. Rational expressions are expressions that can be written as fractions. So this entire unit is on fractions. This is the rational unit. The entire unit is on fractions. Okay? So the first thing we're going to learn how to do is simplify rational expressions. And then tomorrow we're going to multiply and divide rational expressions and then simplify them. And then after that we're going to add and subtract rational expressions and then simplify them. And then we're going to look at complex rational expressions, which is where you have like a fraction on the top and a fraction on the bottom. And then we're going to simplify them. So everything we do is based off of today. This is the final step for every single problem all unit. Okay? Yes? We're going to do keep, change, flip. Yep. So lots and lots of fractions, lots and lots of simplifying fractions, which means this lesson is very important because we're going to do it today. We're not going to forget about it tomorrow. It's going to be the last step of what we do tomorrow. And it's going to be the last step of what we do the day after that. And it's going to be the last step of what we do the day after that. So we are going to be simplifying every single day. Okay. The other thing about rational functions that's important is that it's lots and lots and lots and lots of factoring, which means we cannot be rusty at factoring. We can't be bad at factoring this unit because we are going to factor problems approximately 1,000,000 times between now and when the unit is over. Okay, lots and lots of factoring. It's going to be so fun. Are you excited? So fun. You're welcome. You're welcome. All right, so the first step for a rational expression is to write it like a rational expression. So if you look at example 1 and 2, those are already written that way. But if you look at example 3 and 4, they are not written as fractions. So our first step would be to write them as fractions. Okay. The next step is to make sure that the terms are in descending order, which means the highest exponent is written first, and then the next exponent, and then the next exponent, and the next exponent. Okay? The next step is to factor things, and then after that we reduce common factors, which means if you have a 5 on top and a 5 on bottom, those divide to give you 1, so they basically go away. X plus 2 and x plus 2, those divide to be 1, they basically go away. Okay? When we're done, whatever is left over becomes the simplified term, okay? Now, this is where we have the most often killed animal, which is puppies. This is the unit where you guys will be slaughtering puppies like crazy, okay? And I will be very specific today on what kills a puppy, and then we will be very careful to not kill puppies, and all of you will have many, many, many puppies' deaths on your heads by the end of the unit, okay? Because it is very, very common to kill puppies this unit. So we're going to be very, very, very careful to save the puppies. Sound good? Okay. So, first problem, we do not have to worry about it being written as a numerator over denominator because they already did that. We don't have to worry about descending order because there's just one term on the top and the bottom. We don't even really have to worry about factoring because you don't typically factor something that's just one term. So we're going to go straight to step 4, which is reducing things that are in common. So if you look at 18 over 24, what number could you divide out of the top and the bottom? 6, yeah, 6 and 6. So 18 divided by 6 is 3. Divide by 6, get 3. 24 divided by 6 is 4. And then between x to the third and x squared, what can we take out? X squared. So take out all of the x squared, take out 2 of the x's and leave 1 behind. And so what is our final answer? 3x over 4. Whew. Wasn't that fun? All right. Example number 2, it is already written as numerator over denominator. It's not written in descending order because they actually already did step 3 for us. They already factored it for us. Okay, so see, step 1, 2, and 3 are done. That means we are starting off with step 4 on this example, where we are canceling out the things that are the same. So something divided by the same thing divides to equal 1. And so here, all you can divide is x over x. Those divide to make a 1. The 7 over 3 do not simplify. X minus 1 is an entire group. X minus 2 is an entire group. If you try to cancel these x's, you kill a puppy. That's how puppies die. The reason that it would kill a puppy is because the top is a subtraction problem, the bottom is a subtraction problem, and subtraction and division do not cancel each other out. Does that make sense? So these x's, even though they're the same letter, they do not cancel because the whole factor has to be the same for something to cancel. X minus 1 and x minus 2 are not the same. They do not cancel. If you cancel them, you're killing a puppy. Okay? So the final answer is 7 times x minus 1 over 3 times x minus 2. Most of us will just leave the answer that way, but some students are like, Miss Rice, you should not leave parentheses, and they like to write 7x minus 7 over 3x minus 6, and guess what? Everybody's right. Those answers are both good. They're both full credit. Okay? So you can do either answer. The trick is just to make sure that you understand both answers, because if we do a multiple choice problem, either one of those answers is fair game for a multiple choice answer. Would both of them be multiple choice answers? No, because then you'd have 2 right answers for multiple choice, and that's not fair. Okay, so it would be one or the other, but they're both fair. Yes?
Could the question say, write out the factored form and have those as an answer?
I mean, it could if the teacher's evil, but I'm not evil, despite the rumors.
There's no rumors.
Oh, there's rumors. I've heard them.
Yes.
Yes. I mean, it happens. Okay, let's write the next problem. So, what's wrong with this problem? Example 3. It's not in the right form. It needs to be written as a fraction. So, we've got x squared plus 9x plus 20 divided by x squared plus 13x plus 40. Can I look at this and say x squared, those should cancel?
Which ones?
If you want to kill a puppy. Okay, why can I not cancel these x squareds if they're the same? This is a addition problem. This is an addition problem. Division doesn't cancel out addition. So anyway, as I was saying, yeah.
If the bottom x squared was negative?
No. Because it's still a division problem, right? It's top divided by bottom. So, we cannot cancel these x squareds. We cannot cancel these x squareds because addition and division are not opposites of each other. Okay? We have an addition problem on the top. We have an addition problem on the bottom. They are not going to cancel by dividing two addition problems. Okay? So, when we think about the opposite of division, that's multiplication, right? So if we can write these problems as things that have been multiplied together, then we can do some canceling. That's why we factor, because when you factor, you write 2 parentheses that have multiplied together, and once they're all written as parentheses that have multiplied together, then those parentheses can cancel because division is what would cancel them. Yes?
So you do like x plus 5 times x plus 4 plus 5 times x plus 5.
So if we look at this, we've got numerator over denominator, we've got descending order. Now we're going to do the factored form, because when we write it in factored form, we will know what things have multiplied. Okay? So for the top, we are looking for 2 numbers that multiply to 20, but add to 9, 5 and 4. So on the top, we have x plus 5, x plus 4. On the bottom, we are looking for two numbers that multiply to 40 but add to 13, 8 and 5. So now, instead of having addition on the top and the bottom, we have multiplication on the top and the bottom. X plus 5 times x plus 4, x plus 8 times x plus 5. And if we want to cancel multiplication, we can do division. So what's the division that's going to cancel? X plus 5. X plus 5 divided by x plus 5 is 1. So I'm going to say this one and this one divide to make 1. So they canceled, okay? So that leaves me with x plus 4 on the top, x plus 8 on the bottom. I know that it is so tempting to cancel out those x's, but can we do it? We cannot. That would kill a puppy. I know that it is so tempting to do something with the 4 and the 8, but can we? No, it's an addition problem. Division does not cancel out addition. We are done. Cannot do anything else unless you want to kill an adorable little golden retriever puppy. Very sad. Okay. Example 4. What do we do first? We write it as a fraction. So we got negative 6x plus x to the third divided by x squared over x. Or sorry, x squared plus x. Now, step 2 says to put them in descending order. They are not currently in descending order. The top has an x to the 1 power and then an x to the third power. So what we're going to do next is we're going to say this is x to the third minus 6x divided by x squared plus x. Okay? We have an addition problem, a subtraction problem. We cannot cancel those using division, so we can't do anything right now. So what's our third step? Factor, pull out a GCF. GCF from the top, GCF from the bottom. So when you take out a GCF from the top, what do you get? X times, okay, when you take out a GCF on the bottom, what do you get? Okay, so now it's been written as a multiplication problem, and multiplication and division do cancel. So what are the things that will cancel to make a 1? X over x. Those cancel to make a 1. Can we do anything with the x squared minus 6 and the x plus 1? Nothing. It's a whole group. Unless parentheses are identical to each other, no part of it gets to cancel. That's just how it works. So unless they're identical, no canceling gets to happen. No dead puppies. Okay. Example 5 is already written as a fraction. It's already written in descending order. So that means that our first step is going to be to factor, and I want you to look up at this little box underneath factor, and I'm going to ask you to underline or highlight if you are the type of person who keeps colored pens around. It says to factor out a -1 if the first term is negative, and this is like the easiest little thing that messes everybody up. So it's not hard to do, but it's very easy to miss. Okay, so factor out a -1 if the first term is negative. And then after that, it's just reminding you we've got GCF, we've got difference of squares, we've got diamond problems, we've got slide divide problems. So just after that, it just reminds you of the different types of factoring so that you don't forget, okay? But the easiest step that a lot of students will miss is to take out a -1 if the first term is negative. So if we look at this, the problem is written as a fraction, it's in descending order, so now we're going to factor. How do we factor the top? Difference of squares, x plus 4x minus 4. Now the bottom has a leading term that is negative. That means that in descending order, the first term is negative. Anytime you see that, the first term being negative, anytime you see that, you are always going to take out a negative. Always, okay? So we're going to take out the negative, and then what's left over? X minus 4. Okay, now it's written as a multiplication problem, so now we can do division to cancel things. Cancel the x minus 4. Yes, because the negative is a -1 times that, and so it's just going to leave a negative on the bottom.
Do you
So I am left with x plus 4 divided by negative 1. I could leave the problem like that, but it's a little weird because I know how to divide by a negative 1, right? So what should my final answer be? Negative x minus 4 is the answer that makes the most sense.
On that problem, that almost looks like, the bottom, the denominator is just a factor of the top. Could you just look at that?
It's actually, so if you look at this, we kind of took out factors of the top and bottom, right? We said that 6 was a factor of 18 and 6 was a factor of 24, and that's what made it so we could cancel it. It's kind of like that's what you're doing here too. Is you're saying that x minus 4 is a factor of the top and x minus 4 is a factor of the bottom, so I'm just going to take that factor out. That's exactly right. Okay. Example 6. It's written as a fraction. What do we do next? It is not in descending order, so we're going to fix that. We got x squared, then negative 4x, then negative 5. And then we got x squared minus 2x minus 15. Okay. And then what do? We got a factor. We got to write it as a multiplication problem so we can start to cancel, right? Because if I try to cancel these x squareds, what's going to happen? I'm going to kill a puppy. I don't want to kill a puppy. All right. So we are looking for two numbers that multiply to negative 5 and add to negative 4. Negative 5 and 1. Okay, so we got x minus 5, x plus 1. And then we are looking for two numbers that multiply to negative 15 but add to negative 2. Okay. So we are saying x minus 5 divided by x minus 5 gives us 1. Multiplication and division cancels. And so what are we left with? X plus 1 over x plus 3. Okay. All right, now I need you to get a color of some sort. So colored pen, could be a marker. There's markers over there. There's colored pencils over there. I need you to get a color of some sort. Yes. Wait until we're done with this part and then yes. All right, so we are going to add this to our notes, okay? You can write this on the front or the back. I'm going to go ahead and write it on the back. So what we're going to do is we are going to talk about excluded values. Excluded values. All right, an excluded value is a value that makes it doesn't matter. We have an entire sheet of paper you can write as big as font. A value that makes the rational expression undefined. Okay, so a rational expression is a fraction. There is a value that we are not allowed to have in a fraction. Not an I. Well, you're kind of right about an I, but that's not a square root. We can have negatives in fractions.
Absolute value.
We can have absolute values in fractions. It's a number. It's a very specific number that you're not allowed to have. You can't divide by 0. Right? You can't divide by 0. Okay? So now this is the question everybody likes to ask Siri. Has anyone asked Siri this? What happens if you So division means that you're taking something, some number, and you're dividing it into that many groups, right? So if I have $5 and I divide it among 0 people, how much does each person get? That question is ridiculous, right? Yeah, it's a confusing question. So here we have to make sure that we're not dividing by 0. So whatever number you plug in through the variable that gives you 0, that number is an excluded value, okay? So what I'm going to show you is we're going to go back through each of these examples, and I'm going to show you what the excluded values are, okay? So when we have an expression, we can graph it. You do not have to graph these. I'm just going to show you, okay? So when I graph this first one, it's going to be kind of a funky looking graph. 18x to the third, I'm graphing the original function, 24x squared. I'll go ahead and leave like a normal window. So this is what the graph looks like. Straight line, okay, and that's because we have x to the third divided by x squared, which is just an x, okay? And now what I'm going to do is I'm going to show you what happens if I try to plug in 0. So plug in value for x, plug in 0. What do you notice about the y? There's nothing there. That means that if I was to draw this picture on my graph, I would have to put a little circle at 0 and say that's a hole that's not filled in. Okay? Does that make sense? Because you can't plug in 0, you're going to divide by 0. 24x squared, you're going to have a 0 on the bottom. Okay? So the excluded value here is x cannot equal 0. Now, what I want you to notice, so keep that mental image in your brain. Everyone got that in their brains? Okay? If I delete that, and I do 3x divided by 4, what do you notice about 3x divided by 4? It looks exactly the same. You guys notice that? It looks exactly the same. But if I hit second trace and I plug in 0, I get an answer this time. So what we have to do is we have to say, okay, this was the original problem. I simplified it. But the original problem did not let me have 0. And so I need to say, yes, you can't have 0 still. Because I simplified it, so it should have the same exclusions that the original problem had. Make sense? Okay, let's try another one. So let's look at this one. The original problem said 7x times x minus 1, 3x times x minus 2. I'm going to go ahead and graph it. It's a funky looking graph. Okay. Is this graph continuous? No, definitely not, right? You're going to have to pick up your finger. Okay, so I'm going to show you. We're going to do second trace. I'm going to try to plug in 0. What happens? It's an excluded value. I'm going to try to plug in 2. What happens? It's an excluded value. Okay, so I'm going to write on here, x cannot equal 0 or 2. We have 2 excluded values for that one. I think you're going to pick up on where the excluded values come from. So I'm just going to tell you what a few of them are, and then we're going to see if we can figure out how I knew. Okay? Now, if I graph our answer, I've got 7 times x minus 1 over 3 times x minus 2. What do you notice about the picture? Looks the same. Now, if I try to plug in 0, it's not excluded anymore. Because I canceled it out. Does that make sense? I canceled out the x's. And the x's were the part that made it 0, so 0 was a problem. Now, if you look here, I'll plug in 2. 2 is still an excluded value. But since I simplified the problem, I wasn't trying to make the problem equal something else. I was just trying to simplify it, right? When you have 50 over 100 and you rewrite it as 1/2, you're not saying it's different, you're just simplifying it. Does that make sense? So when I simplify this, I just need to specify, okay, I took out some information from the problem. That information was important because it told you specific x values you could not have. So I'm saying now the problem is a little bit more simple, but I should still not use these x values because the original problem said not to. Yeah. You're going to see in a second. I'm going to keep going. Okay, we're going to do the next one. All right, so if I graph the next one, I have x squared plus 9x plus 20. I don't need a parenthesis, divided by x squared plus 13x plus 40. Yeah, they make weird looking graphs, don't they? All right, so my first excluded value is -8. And you see when I try to plug it in, it gives me nothing. My second excluded value is -5. I try to plug it in, it gives me nothing. Do we see that? Okay. Now I'm going to go ahead and write that down. X cannot equal -8. It cannot equal -5. And if I write our simplified answer, x plus 4 over x plus 8, what do you guys notice about the graph? It looks the exact same as it should, right? Because these are simplified forms. If I try to plug in -8, I still can't have it. But if I try to plug in -5, I get an answer this time. So I have to specify these two values are excluded with this new answer so that they know I simplified it, but you really couldn't have that value because the original problem said no. Okay? All right. On the next one, the excluded values are 0 and -1. I am not. On the next one, the excluded value is +4. Not yet. On the last one, the excluded value is -3 and +5.
Wait, why for example 5?
Mm-hmm.
Wouldn't it be -4 or would you
It would be +4.
Oh, I think I got it.
4 over and then divide by -4?
So, where do the excluded values come from? Denominator, right? And that makes sense, right? Because we can't divide by 0. And then what about the denominator? The factors. We're looking at the factored form. And what about the factored form? Yeah.
Your number just doesn't have an x on it. Is stuff like this. So let's take problem number 3 for an example. So you see at the end, at the denominator there's a 40. And what x not equal is -8 and -5. By -8 and -5 you get 40.
So if we look at this, when we look at the factored form, if you see this factor, it says +8. So if I plug in a -8, what's going to happen? It's going to zero out. And then that makes the whole bottom 0. If I take this factor and I plug in a -5, what's going to happen? It's going to zero out. So the way that you find your excluded values is you just look at the factored form on the bottom before you cancel anything. You can't look at it after you cancel. We got to look before we cancel. So we look before we cancel, and then it's the opposite sign of whatever those factors are. How did I know if an excluded value was 0? There's a plain old x by itself. So if we look at this, it was x and x. That's what canceled. See the x by itself, 3x? Okay. If we look at this one, it had an x by itself on the bottom. They had a coefficient, but we don't care about that. Okay. So if there's an x on the bottom by itself, that's going to be an excluded value of 0. The excluded values of the numbers just come from the opposite sign of the factors. All right. And it just makes the whole bottom 0, which we're not allowed to have. Okay. How are your brains doing? Kind of makes sense? Okay. All right, let's do some of these problems, shall we? So, Hey Gunnar, take a seat, please. All right. So they want us to simplify. If I've got 90 on the top and 45 on the bottom, what could I divide out of those? 45, yeah, 45 goes into 45. It also goes into 90. So 45 divided by 45 is 1. 90 divided by 45 is 2, okay? What about p squared and p? P. So take the p out. On the p squared, we're going to take one of them out and leave one behind. And so what do we have? Negative 2p over 1, but nobody's going to write that over 1. We're just going to say negative 2p. And yeah, but it's not x, it's p. And what p value can you not have? P cannot equal 0. Okay, let's look at the next one. Between 12 and 54, yeah, you can definitely take out 6. Let's try it. So divide by 6, you get 2. Divide by 6, you get 9. Okay, what else? M, so take out an M, and that one's gone. Take out an M, and you leave 2 behind. So what do we have? 2m squared over 9. Okay. Now, I'm not writing the excluded values because the problem didn't say I had to. All right, but if we wanted to say the excluded value, what would it have been? 0. Can't have 0 on the bottom. There's an m on the bottom of the original problem. That means no 0. Okay. Let's jump down to number 9. What cancels on number 9? 6 and x, yep, or 6x and 6x, however you want to do it. All right, and then what's our final answer? 3x plus 4 over 5x plus 6. Anyone know what the excluded values would be? There's 2. Negative 6. Wait, negative 6. It's a fraction. Negative 6/5. And then what about this one over here? 0. We're not looking at the top. Because you can have 0 on the top of a fraction, it just zeroes out the whole thing. You just can't have 0 on the bottom of a fraction. Okay, now you didn't have to have the excluded values, the instructions didn't say it, but it's good practice, right? Okay, what about number 11? I see some stuff that cancels. The ends, right? And the parentheses are identical, so they cancel. You're close. You can use your cheat sheet also. Oh, that was an extra on accident. Pretend it's not there. Yeah. Yep. So, sorry, what do I have? 4 over 5, because 8 over 10 simplifies to 4 over 5. And then what would our excluded values be? 0 and negative 1. Not always. It's just because we've had a bunch of problems that had a plain old x. Like this one, number 13, 0 is not an excluded value. Okay, so what can we cancel on number 13? Okay, so n minus 10, n minus 10. And what do we have left over? Can we cancel anything else? The ends, maybe? No, don't want to kill a puppy. I tried to kill a puppy. You guys wouldn't let me. I appreciate it. Okay. What are the excluded values? 5 and 10. How could I check the excluded values if I wanted to make sure I got them right? You could graph it, try to plug them in. Okay? When you check the excluded values to see if you're right, do you graph this problem or do you graph this problem? The first one. You graph the original problem. Okay. Let's go ahead and flip it over. Let's look at number 16 because there's some big numbers there. All right, so it's written as a fraction. It's in descending order. It is not factored, so that's what I need to do. What type of factoring is it? GCF. And what's the GCF? 9. 9M. And then 3M minus 8. Okay, and then what's the GCF on the bottom? 9M. 7M. Okay. And then what cancels? The 9M and the 9M. And we are left with 3M minus 8 over, okay. What would the excluded values be? It'd be 4/7, you're right. 4/7 and 0. Okay. So your homework tonight, we got about 10 minutes. Your homework is to finish this worksheet. And we have a video. Let me check.